This lesson will be on 11-5, dividing polynomials. There'll be three types or three ways to divide monomials. The first way is when you're dividing a polynomial by a monomial. So for example, if we're given a problem like 3r squared minus 15r, and we're dividing this binomial by a monomial 3r. The second is to divide a polynomial by a binomial. So for example, if we're given a polynomial s squared plus 6s plus minus 7, and we divide this by the binomial s plus 7. Notice that s squared plus 6x minus 7 is factorable. The third example will be to divide a polynomial by long division. So in this example, we'll be taking a polynomial x squared plus 3x minus 24, and we'll be dividing it by x minus 4. Notice that in this expression, x squared plus 3x minus 24, this is not factorable. So when you have an expression that's not factorable, you'll have to divide the polynomial by long division. In example 1, we'll be dividing 3r squared minus 15r by 3r. So when we take a polynomial and divide it by a monomial, we can set this up as a fraction. Remember that when we divide fractions and there's an expression on the top, what we can do is instead of dividing the entire expression by 3r, we can divide each term by 3r, like so. Now we can reduce each one of our fractions. So 3r squared divided by 3r. Let's do this in a different color. The 3's cross off, and r crosses off. One of the r's on the top cross off, and we have r. Negative 15 over 3 reduces to minus 5, and the two r's cross off, so our answer is r minus 5. In example 2, we'll be dividing s squared plus 6x minus 7 by s plus 7. So we can first start by setting this up as a fraction. Now, if you notice, s squared plus 6s minus 7 can be factored into s plus 7 times s minus 1. Remember, we're looking for the factors of 7 that subtract to give us 6, which would be 7 and a minus 1. So let's factor that expression into s plus 7 times s minus 1. And now that this is factored, we can reduce. So our answer is s minus 1. In our next example, we have 3x squared plus 3x minus 24 divided by x minus 4. However, in this example, our trinomial is not factorable. When we look at the factors of 24 that subtract to 3, there are none. The factors of 24 are 1 and 24, 2 and 12, 3 and 8, 6 and 4. And none of these subtract to give us 3, a positive 3. So what we'll have to do is long division. Let's get rid of all of the factors of 24, and then we'll set up our long division. So in long division, here's our long division bar. We're going to divide x squared plus 3x minus 24 by x minus 4. And this works the same way regular long division goes, except we only have to worry about or look at our first term here of x. X times what right here would give us an x squared. So an x times an x would give us an x squared. And in long division, now we'll multiply. So we're multiplying this x right here times our expression x minus 4. So x times x minus 4 is x squared minus 4x. Now, in long division, after we multiply this times this, we now subtract our answers. But we have an expression that we're subtracting, so we will have to take this negative sign right here and distribute it to our expression x squared minus 4x. So if we distribute a negative sign, this will become a negative x squared, and this will become a positive 4x. X squared minus x squared will cross off, and we'll have 3x plus 4x, which is 7x. And then now we can bring down our minus 24. Again, we'll be looking at the x right here, and we'll be deciding x times what will give us a 7x. So x times 7 will give us 7x, and now we'll multiply our 7 times our x minus 4. So 7 times x gives us 7x. 7 times a negative 4 will give us a negative 28. Our next step in long division would be to subtract our two expressions. So we'll need to use the distributive property with our negative sign. So we'll be distributing this negative sign to our parentheses, which will mean that we'll have a negative times 7x, and then a negative times a negative 28 will make this a positive 28. And now we can actually subtract. 7x minus 7x will cross off. A negative 28, a negative 24, and a positive 28 will give us a positive 4. This will be our remainder because there's nothing we can multiply x by to give us 4. So our answer is x plus 7, that's from right here, plus 4 divided by x minus 4. Here's another example of dividing a polynomial by a binomial where we'll have to use long division. If you notice the factors of 12, we first look at the factors of 12 for factors that add to 3. So we have 12 and 1, 2 and 6, 3 and 4. None of these add to 3, so we'll have to use long division. Set up our long division. We have y squared plus 3y plus 12 divided by y plus 3. Y times a y would give us a y squared, and now we'll multiply y times y plus 3. Y times y gives us y squared, y times 3 gives us 3y. And now we'll distribute our negative sign to our bottom expression. A negative times a y squared will be a negative y squared. A negative times a 3y will give us a negative 3y. And now we can subtract. Y squared minus y squared crosses off. A positive 3y and a negative 3y crosses off. And we'll bring down our 12. This will be our remainder. So our answer here is y plus 12 divided by y plus 3. In our last example, we'll be dividing the trinomial a to the third plus 8a minus 24. First, notice that we start with an a to the third power. and then plus a to the first power. We're missing an a to the second power. And this trinomial would not be factored the way that it is. So when we set up our long division, we'll have a to the third, but we need to hold the spot for the a to the second power. So we're going to put plus 0a squared plus 8a minus 24. That's just going to help us out as we're doing our problem out, so that when we divide, we are lining everything up correctly. So we'll have a to the third power plus 0a to the second plus 8a minus 24 divided by a minus 2. Now a times a to the second will give us an a to the third, and now we can multiply a squared times a gives us an a to the third power. A squared times a negative 2 gives us a negative 2a. See right here, this is why we need the 0 a to the second power, because if we didn't put that here above the negative 2a to the second, we'd have the 8a, and we wouldn't be able to add those two terms together because they're not like terms. Now we'll need to subtract our two binomials, but in order to do that, we will have to do the distributive property with our negative sign. So a negative times a to the third gives us a negative a to the third. A negative times 2a squared gives us a positive 2a to the second. Now we'll combine. Our a to the thirds cross off. We have 0a to the second plus 2a to the second. So we're going to get 2a to the second. And we'll bring down our plus 8a. Now a times a positive 2a will give us a 2a squared. So 2a times a gives us 2a squared. 2a times negative 2 gives us a negative 4a. Again, we'll do the distributive property with our negative sign, so we can subtract. Negative times 2a gives us a negative 2a. A negative times 4a gives us negative 4a. Now we'll subtract. 2a minus 2a crosses off. 8a plus 4a will give us 12a, and we'll have minus 24. We'll bring down our 24. Now 12 times a will give us 12a. So 12 times a is 12a. 12 times a negative 2 gives us a negative 24. As always, we'll have to distribute our negative sign, so a negative 12a and a positive 24. This will cross off, so will this. So our remainder is 0. So our final answer is 2a squared plus 2a plus 12.